Welcome to Pythagorean Theorem with Mr. Hubble. This is going to summarize the Pythagorean Theorem in a couple slides and about 3 example problems. So the Pythagorean Theorem is a squared plus b squared equals c squared. You want to use it when you're missing one side on a right triangle. A and b are legs, c is the hypotenuse. So again, if you have a right triangle, as you have in triangle ABC, then if you square leg 1, add it to the square of leg 2, it equals the hypotenuse squared, which is a squared plus b squared equals c squared. That is Pythagorean's theorem. A squared plus b squared equals c squared. Also remember that the hypotenuse is always the longest side, is located opposite the 90-degree angle, and A and B are legs which form the right angle. So again, C is your hypotenuse, B is a leg, A is a leg. The only thing you have to remember that C will always be the hypotenuse, A and B will be legs. With Pythagorean theorem, you also have a Pythagorean triple, which is a set of numbers to satisfy the Pythagorean theorem. They also have to be whole numbers. In other words, they have to be integers. So example 3, 4, 5 is a Pythagorean triple because 3 squared plus 4 squared equals 5 squared. Therefore, 9 plus 16 equals 25, 25 equals 25, which is true. Therefore, all numbers are integers or whole numbers, and the Pythagorean theorem is true. Therefore, it's a Pythagorean triple. More Pythagorean triples are 5, 12, and 13, 8, 15, 17, 7, 24, 25. Again, those 3 sets are Pythagorean triples because they satisfy the Pythagorean theorem and they are whole numbers. There are many more Pythagorean triples out there. I'm just giving you a few examples and to tell you what a Pythagorean triple is. Now let's get into one example problem. Here they're asking what the hypotenuse is of triangle ABC and if the hypotenuse forms a Pythagorean triple. So I know my Pythagorean theorem is a squared plus b squared equals c squared, where a and b are legs. I'll label a and b. So a is 20 squared plus 21 squared equals c squared. So if we square 20, we get 400. We square 21, and we get 441 equals c squared. We add them up and we get 841 equals c squared. We do inverse operations to get rid of the square root. Or we do the square root to get rid of the square. Square root of 841 is equal to c. Now we have to check, is 841 a perfect square? It is. It's 29. So 29 equals C. (29), 21, and 20, are they Pythagorean triples? Yes, it is a Pythagorean triple. They're all whole numbers and they satisfy the Pythagorean triple or theorem. So 21, 29, and 20 Pythagorean triples because they satisfy Pythagorean theorem. Let's do example 2. We have a right triangle with lengths 10 and 24. They want to know the hypotenuse. If they want to know the hypotenuse, automatically label it C. So we know that 10 squared plus 24 squared equals C squared. We have 100 plus 576 equals c squared. We have 676 equals c squared. To get rid of the square, we take the square root of both sides. We take the square root of 676 to see if it's a perfect square. It is. So the square root of 676 is 26. Square root of c squared is c. Therefore, c is 26. So 10, 24, 26 are a Pythagorean triple. Why? Because they're all whole numbers and integers, and the Pythagorean theorem is true. And last example is what happens if you're trying to find a side length. So let's label C, B, and A. And we're going to use, again, Pythagorean theorem. Why? Because we're missing a side length in a right triangle. A is x squared, B is 8 squared, and C will be 20 squared. So we simplify, isolate the variable. We do 400 minus 36, and we get 364. Take the square root of both sides. I'm sorry, this is not. It is 400 minus which is 336. And we take the square root of both sides. And we get x equals 4 square root 21. How do you get 4 square root 21? You have to find the highest perfect square that goes into 336. So what's the highest perfect square that goes into 336? It is 16 times square root 21. So 16 times 21 is 336. 16 is the highest perfect square. So square root of 16 is 4. What you're left over is square root 21. So to summarize, use the Pythagorean theorem when you are missing two sides, or when you are missing one side of a right triangle. To find the hypotenuse, C is going to equal the square root of a squared plus b squared. To find the missing leg, A is going to equal the square root of c squared minus b squared. If you have any questions, please see me after class or after school, before school.